Question number 8, it says, does the right Riemann sum underestimate or overestimate the area of the region under the graph of a function that is positive and decreasing on the interval AB? All right, so let's just do a little model. We'll call this A, and this is B. Let's just make a couple of partitions. Not really, doesn't matter. And let's say we have a positive function, but it's decreasing. So something that is kind of like decreasing, could be a straight line, could be a curve, doesn't matter. Now we're going to do the right Riemann sum. So I will extend each line up until it touches the graph. And we're going to make rectangles going from the right to the left. So the right point, end point is B. I'm going to go backwards and make a line. So just a little bit underneath. And then from this point where it touches, I'm going to go backwards and make a line. And so since this is decreasing, as I go from right to left, it looks like it's increasing. But each time I draw a connecting line to make a rectangle, since this is a right Riemann sum and a decreasing function, each one of these rectangles is below. So this partition, this partition, this partition, this partition. And we can see that each of these rectangles are underneath this positive decreasing line. And so it should underestimate this Riemann sum, or the area under the curve. So A says underestimate. The rectangles all fit under the curve, and that looks appropriate. All right. Number 9 says the velocity of a moving object moves along a line given by this function on the interval 0 to 4. We're going to divide the interval into sub-intervals, 0 to 1, 1 to 2, 2 to 3, and 3 to 4. Each interval, on each interval, we're going to assume the object moves at a constant velocity equal to the value of B at the midpoint of the sub-intervals, and we're going to use these approximation to estimate the displacement of the object, and then we're going to repeat for 8 sub-intervals. All right, so for these sub-intervals, we're going to approximate the displacement that the object is in feet. Okay, so what I'm going to do is draw a sketch of what we're looking at. So since this is a t squared, looks like we will have a parabola, so let's just say up 5, we'll have something. May not be drawn to scale exactly, okay, but some kind of parabola. 1, 2, 3, we'll call this 4. So we're going to have it from, from 0 to 1, so let's say 0, 0, 2, 4. Okay, I don't know what this part is, but let's just call it right here 0. Let's call this 0. All right, so we got 0 to 1, 1 to 2, 2 to 3, 3 to 4, and it says we're going to evaluate it at the midpoint. So halfway is going to be a half, or 0.5, and we can just add 1 because each interval's width is a 1. Okay, so you add 1, that'll land you at 1.5, and that'll land us at 2.5, and then 3.5. And then that'll be it. So we'll have these rectangles, 1, 2, 3, 4 of them, using the midpoint. Now the way the midpoint works is it goes straight up and hits the graph, and then it extends until it hits these other endpoints. So a part will be above and a part will be below, depending on how the graph looks. But mainly we're going to be finding the height of that rectangle, and we're going to do times the width, but the width of each rectangle will be 1. And so we just need to add up all those heights. And so in order to get those heights, I'm going to use the calculator, 4t squared plus 5. So I'm going to let the calculator give me these exact values. Go to y equal. Now the calculator uses x as our input, so we're going to do 4x squared plus 5. Okay, verify that looks good. 4x squared plus 5. Actual function is 4t squared plus 5, same. And then we're going to graph it. So get a parabola. I'm going to trace. This allows me to input values. And then I'm going to start inputting these midpoints, the values that we want to find. And so I want to add up, I'm going to do 0.5. And 0.5 gives me a y value of 6. So for our midpoint, we have 6 plus, and if I do 1.5, gives me a height of 14. And then 2.5 gives me a height of 30. And then 3.5. 3.5 gives a height of 54. Now, the textbook shows you that you can, this is just the height. We didn't do the base. The base is the change in x, and the change in x for each one of them was just 1. The width of each of those section was 1. So you'll do all of this and it'll be times 1. It's the same thing if it was distributed. So I just didn't write the 1. But you do the change in x times that f of x, f of kx. This was a function, I think they did k, was it k star x? I can't remember. I go back and look at it. But the height and the width, add them all up. All right, so this gives me 20 plus 30 is 50, and that gives us 104 once we add it. So we're saying the area bounded by the x-axis between the curve and 0 to 4 is going to be 104 for the midpoint. All right, and then part B says 8 subintervals. And I think we're still using the midpoint. Repeat part A for 8 subintervals. And it just says see the figure. So we can look here. It does show us a image of what it should look like. And so they are using the midpoints, but we're going to divide it into 8 sections now. So what does that look like? 0, well, I guess I say 4 minus 0. That's going to give me 4 divided by 8. That's going to give me 1/2. And so this time, we would break this number line 0 to 4. We would still have the same tick marks, but the one that we would count would be a little bit different. So this time our width is 1/2. And so this will be 1/2, and then 1, and then 1/2, I'll say 3/2, and then 2, and then 2/2, so I'll say 5/2, and then 3, and then 7/2, which is 7/2, and then 4. So these will be our 8 tick marks, but we're going to use the midpoint of these. So if I do halfway between 1/2 and 0, that's going to give me 1/4, 0.25. And so we'll be doing a fourth. So we'll have 8 sections, a fourth. And since my width is 1/2 now, I'm going to add 1/2 each time. So a fourth. And then the next one would be 3/4. And then 5/4. And then 7/4. So 1, 3, 5. So 1, 3, 5, 7, 9, 11, 13, and 15/4. So these are going to be my midpoints. 1, 3, 5, 7, 9, 11, 13, and 15. So I'm going to get the heights of all of these, and when I get those heights, we're going to multiply by the change in x. The change in x this time is 1/2. That's each interval is a half. Sorry, we can't even see all that I'm writing down here. So that's going to be the process. Again, we're going to use the calculator to kind of help us get those numbers because it's a lot when you're plugging it in by hand. So I'm going to go back to the graph. It's the same curve. And my midpoints this time are fractions. So I'm going to say 1 divided by 4 instead of 0.25. Just do it in fractions. 1/4 gives me 5.25. All right, and then 3/4, 7.25, and then 5/4, 11.25, and then 7/4, 17.25, and then 9/4, 25.25, (11/4), 35.25, and then 13/4, 47.25, and then 15/4. 15/4. Okay, so provided that did not type anything in incorrectly, 61. Okay, these are the values we should get. And so I'm going to get out of this, and I will type all of these in and multiply by 1/2, because these are all our heights times our base is 1/2 to get the area of the rectangles and add them all up. So 5.25 7.25 11.25 17.25. Just double check before it starts sliding. So we got 5, 7, 11, 17. Could have just added all those up and said 2. So we do whole numbers, but we're there. 25.25, 35, 35.25, 47.25, and then 61. All right, we'll close that, and then we'll multiply this by 1/2, because our base times height. All right, and that gives us 105. So the first time we did it, we got 104, okay, with the midpoint and just doing 4 sections. Now we've done 8 and do the midpoint, and we get a little bit closer approximation. So the more rectangles you make, the closer you get. So we are getting approximately 105 for the second calculation.